So my presentation is on magnetic resonance imaging and physics. What is an MRI? Magnetic resonance imaging, or MRI, produces three-dimensional detailed anatomical images through the use of magnetic and radio waves. This process is non-invasive, meaning it does not enter the body, and is often used in the medical field to detect, diagnose, and treat diseases. When are MRI scanners used? One incidence is when studying tissues of the brain. It can be used to diagnose tumors and aneurysms, and it can be used to diagnose mental health disorders and their effects on the body. MRI scanners can also be used to view internal organs and their structures. MRIs are unique in the way that they produce cross-sectional images and 3D pictures. MRIs are also used for cancer screening, as it can record the spread of the cancer cells through the body. And the last example that I chose was viewing muscles, ligaments, and tendons. MRI scanners are used to diagnose injuries, and they're unique because they do not act like X-rays or CAT scans, but they actually show a three-dimensional picture so you can actually view the muscles, ligaments, and tendons in the body. The physics behind MRIs. So the MRI machine itself is basically a giant magnet. Most MRI machines in hospitals range from 1.5 Teslas to 3 Teslas in size. If you are relating this strength to Earth's magnetic field, MRIs are about 60,000 times as strong. The physics behind MRI continued. MRI uses magnetic fields and radio waves to measure the amount of water in different body tissues. Since our body is comprised of about 65% water, the current is easily obtained from the human body. Hydrogen protons present in water are used to measure the signals from the body. Each hydrogen proton serves as a tiny magnet spinning around its axis. All hydrogen atoms are randomly positioned throughout the body. The randomness of these protons changes in the presence of a very strong magnetic field, in this case the MRI. This scanner aligns the protons like a compass and makes them either face north or south. The next slide shows a graphic that elaborates more on this process. How the frequency works. So atoms spin in random directions like a top around their individual magnetic fields. In magnetic field produced by the MRI, atoms line up either north or south, like I mentioned before. About half the atoms go each way, but there are still a few unmatched atoms. When radio frequency pulse is applied, the unmatched atoms spin the other direction. When the radio frequency is turned off, the extra atoms return to normal position and they emit energy. This energy sends a signal to a computer. The computer then uses a mathematical formula to convert the signal into an image. The radio frequency used in MRI scanners is specific only to hydrogen atoms, and the pulse given off by the machine is directed toward the specific area of the body that is to be examined. How the frequency works continued. 3 different gradient coils assist in the operation, depending on the bodily position being observed. The coils are arranged in such a way that when they are turned off and on rapidly in a specific manner, the magnetic field is altered to view a specific part of the body. After the radio frequency pulse stops, the protons release their absorbed energy and return to their previous random alignments like before. This emits a certain radio frequency back to the coil, which is calculated based on the tissue being imaged and the strength of the main magnetic field using the mathematical formula we talked about before. In conclusion, the topics related to Physics 1402 that I used are charged particles and outside forces, which in this example was protons, and the outside force was magnetism. Magnetic fields are also discussed, since an MRI machine is basically a big magnetic field in itself. And the third topic that I discussed was the electromagnetic spectrum, specifically radio waves and their effect on hydrogen atoms in the body. Each of these topics relate to each other in the process of magnetic resonance imaging to assist healthcare professionals in diagnosing their patients. MRI machines are just one example of how physics is used in the everyday world. And here is my works cited page, and it has several links to the information that I gathered about the subject and how it relates to physics. Thank you.